Okay. So, let us start last class we have discussed about that engineering models of the speech production systems. We said that this vocal tube can be modeled as a filter and glottis vibration can be modeled as a source. So, we said the source filter model, we said this is a filter, that is let us HS, and there is a source called ES, or I can say EN and HN in digital system, and the output is the speech, either SS or small s n. Okay. So, now if I say that this is a filter, okay. So, if the source exists, so all voice sound, the source is modified by the filter, and source has only property the fundamental frequency contour, and it is nothing but a impulse. So, if you say here in the slides, so it is nothing but a impulse. So, excitation generation nothing but a impulse, and that excitation is coming through a filter which is modeled as a linear filter. Why we consider linear filter and how this model is mathematically described, we will discuss later. So, this is nothing but a linear filter, and convolution of En and Hn produce speech. So, in time domain if it is convolution, frequency domain it is nothing but a multiplication. So, now how do I classify the voice sound? So, voice sound is classified based on two properties. One is the fundamental frequency of the excitation, which is constant for throughout the all voice sound. Now, different model of filter can produce different voice sound. So, if I say, as you know, HS is nothing but HS is a filter model, that is nothing but a sum PS by QS, as you know in any model is nothing but a pole and 0 kind of combination of pole and 0. So, root of this thing is provide me 0 and root of this thing is provide me the poles. So, now you know as per that control systems, if you have that background of electronics, that all pole related to the formant frequency or resonance frequency, later on resonance frequency. So, for every pole there is a resonance frequency. So, if QS is a first order system, then it is only single pole. So, I can the single resonance frequency. If it is a multi order system, nth order, so n number of resonance frequency will be there. So, if I look at the frequency response of this linear system, it will look like this. If you see, look like this. So, every peak is called formant. So, all voice sound are characterized by those formant. So, this is first formant, second formant, third formant and fourth formant, so on, the formant will be there. So, if it is frequency domain, if this axis is frequency and this axis is the amplitude of that frequency and omega is the analog frequency, it is associated in analog frequency, then it is nothing but a multiplication. So, this frequency response of the unit impulse will be modified by the filter frequency response. Details of what should be the formant structures will come on when we model this speech production system. So, all the voice sounds are characterized by the formant frequency, but different voice sound has different kind of formant frequency, that is why they sound like different sound. So, then if just this we have already explained that why that woman has shorter F0 and formant frequency, then I have go to this directly. So, there is some average F0 value. If you see the average F0 value for man is F0 average 150 hertz and minima is 80 and maxima is 200. If you say the woman, it is average is 225, almost above 200 hertz, and children it is above 300 hertz kind of mean frequency. So, if you that you have experienced that if you see, if you know the singing, so bass frequency that somebody has B sharp, B flat, those kind of scale you are using, that is nothing but a match with your average F0 frequency. Okay. Now, formant frequency also I will come on what should be the human minimum formant frequency, and all those variation I will come on when we discuss about the uniform tube modeling of the speech production system. So, any voice sound I can say that it is characterized by the formant frequency or resonance frequency. So, formant frequency is nothing but the resonant frequency. So, if I say any voice sound, vocalic sound, if this is frequency and this is amplitude, it will be look like this. So, this is first formant F1, this is F2, this is F3, so on F4, so on going on. Okay. Once it is going up, the amplitude will be going down, that we will discuss why this is going down. Okay. Now, if the voice sound is characterized by the formant frequency, so formant frequency depends on the structure of this vocal tract. How this formant frequency will change depending on the HS. So, HS will be modified based on the structure of the whole tube. So, different structure can produce the different kind of voice sound, and this has the different kind of formant frequency. Now, if I related to the vowel sound, if I related to the sound which is unvoiced sound, we can say that there is a difference between the unvoiced and silence. So, aspiration, friction are called unvoiced sound. Unvoiced means vocal cord is not vibrate, but still there is a noise kind of sound. The source is aspiration and friction. How the aspiration is produced? Suppose you have a tube, you create a narrow constriction in the tube. Now, what will happen? The air pressure, lungs produce an air pressure and you create a narrow constriction using the tongue. Then what will happen? The force air try to find out a path, and there is a friction kind of noise sound will be generated. So, those kind of sound is called aspiration and friction sound will be generated. So, details I will come in that manner of articulation and that place of articulation discussion. Now, forget about the signal processing engineering model part. Human vocal tract produce different kind of sound. How do I classify those sound? How do I describe? Forget about the classification. I want to describe the different sound produced by the human being for speech communication. Okay. So, I can say that whatever the sound is coming out from the mouth has two property. One is the tongue position, how the tongue is moved and to produce that sound, that is, and place, where it is placed, the position means where the sound is produced, that is called place of articulation. So, during the articulation, the air stream through the vocal tract must be obstructed in some way, so that I can produce the sound. The place where the obstruction is take place is called the place of articulation. For example, suppose I want to produce the vowel a. So, I can see the vocal cords is vibrating and hip of the tongue is raised a. So, the place where the obstruction is happen is called place of articulation. And manner means how I produce that sound. That means when I produce the sound, the air flow, whether the air is freely flow, whether the air flow is stuck, whether the air flow is passes through a narrow cavity. So, all kind of air flow mechanism are produced the manner of articulation. Now, you can see the manner of articulation has also two major difference. One is called either this vocal, if I say the source is also part of manner of articulation, then either source can present or source can absent. So, either glottis can vibrate or glottis can absent. So, glottis has two manners. When the glottis is closed, then the voice sound is produced. When it is totally open, then the unvoiced sound is produced. So, anything can be voiced or unvoiced. So, two parts based on the glottis, it has two parts, either it can be voiced or it can be unvoiced. Similarly, place of articulation has produced different sound. How do I describe the place? So, different place are, if you see, the bilabial, labiodental, dental, alveolar, postalveolar, retroflex, palatal, velar, uvular, pharyngeal and glottal. So, if I see the upper track of the human speech production system which is there in here, if you see the different upper cavity can be part in different place, bilabial, then dental, then can be labiodental, means lip and dental can be there, or I can draw that. This will be very easy if I draw it. Let us I draw a human speech production system. I do not find that duster. So, if I see it, that schematic diagram of the human speech production system, I want to draw it. So, if I see, I start from labiodent, bilabial, labial, then it can goes to the teeth, palatal, and then goes velum. So, there will be a velum cavity in velum, then so lower cavity is bilabial, teeth, and then tip of the tongue, and then come in the voice. So, here either glottis can close or open. If it is closed, then I call voice sound. If it is open, then I call unvoiced sound. Now, if the tip of the tongue touches the teeth, then I call it is a dental sound, or blockage can be happen in here, constriction can be happen in labial position also. So, this is called labial, lips, dental, then you can say the post alveolar, post alveolar, velar. So, all kind of place I can show you in different schematic diagram, all kind of place for different kind of sound production systems. Okay. Now, so depending on the place, the sounds are classified in different labial, bilabial, when the sound are produced two lips, labiodental, when the sound are produced by a constriction of a lower lips with upper teeth, dental, when the sound is produced by the constriction of tip of the blade of the tongue with the upper teeth, ta, pa, labial, bilabial, pa, bilabial, two lip are close together to produce the pa, bilabial, then ta. If you see the tip of the tongue touches the dental position, so it is ta, dental. Then alveolar, the sound made by tip or the blade of the tongue with in the contract against the alveolar region, after the teeth, the alveolar region, then we call say alveolar sound. Then after alveolar there is a post alveolar. Then after post alveolar, retroflex sometime it is not a place of articulation, it kind of manner of articulation, when the tip of the tongue curl back and touches the upper cavity in post alveolar region, we call retroflex sound. So, tip of the tongue curl back, ta. If the tip of the tongue is curled back and touches the upper cavity, that is why it is called retroflex sound. Similarly, if I say there is a palatal sound, when the constriction made in the front part of the tongue with the hard palate means middle of the cavity, hard palatal region, when the palatal region is come, then it is called palatal sound. Then after the palatal, there is a velar sound, when the back of the, now that see that, after here tongue cannot go back. So, the back of the tongue can also move. When the back of the tongue raise and touches the velar position to produce the sound, we call velar sound. K. If you say k, then back of the tongue is raised and touches the velar position, then we call velar sound. Similarly, alveolar, pharyngeal and glottal sound. When the sound are coming from the glottal region, we call glottal sound. Okay. So, depending on the place of the constriction, sounds are described, and that description is called place of articulation. Because the constriction is made different position, so tube structure will be different kind of frequency will be produced by the tube, and that is why the sound is different. Okay. Now, if I go to the manner of articulation, as I described, the manner of articulation depending on the source, glottist has two manner, either it is voiced or unvoiced, or aspiration is there. So, voiced, unvoiced and aspiration may be there. So, these three are the source, and there is another manner of articulation which is called plosive or stop, nasal stop, fricative, nasal stops or plosive, fricative, lateral, approximant, trill, flap or tap. What do you mean by the plosive sound? Now, if you see, if of the tip of the tongue close the upper cavity, if I say paw, let's two lips are close together, paw, what is happening? In the back cavity, before the closure, so if the closure is here, then the sound, the air pressure in here is building up, because the cavity is closed, paw, and suddenly this is released and some burst is coming out, sound burst is coming out, paw. That is why it is called plosion or plosive, paw, plosion. So, if the sound is, if the consonant sound, this is called consonant sound, if the consonant sound is followed by a vowel, paw, then what is happening? Now, back of the cavity sound pressure is increases, it creates a plosion, that is why it is called plosive. Sometimes, suppose if I say ak, or ak, then what is happening? There is a vowel sound is producing by the vocal tract, and suddenly it wants to produce a consonant, you want to produce a constriction. So, it is want to stop, so then it is called stop sound. Okay. So, plosives or stops, it can be either plosive consonant or it can be a stop consonant. So, if it is followed by a vowel, then it is a plosion will be happen. If it is after vowel there is a sound ka, then it called this ka is stop, it is not plosive. Okay. So, this is plosive and stop. Then nasal stop. Sometime if you say na, ma, bilabial nasal, ma, ma. So, if the velum is open, that is why it is called nasal cavity is attached. So, this is nasal sound. Then there is a fricative, affricate, lateral, approximant, fricative. If I say sh, sh, so it is fricative sound. Affricate sound has a two property. Affricate, first part is plosion, second part is friction. That is why it is called affricate sound. I will show you animation for that. Affricate means first part is plosion, second part is friction. That is why it is called affricate sound. Then lateral sound. If you see the tip of the tongue touches the upper cavity and sound is coming the two side of the tongue, la. So, side of the two side are open and the sound is or air is coming out from the two side of the tongue, then it is called bilateral sound. If it is one single side it is coming, unilateral sound. So, it is lateral sound. Okay. Then approximant, like that we have Bengali has two approximants. So, approximants are look like a vowel, ya, and if I say hawa, wa, and approximant or glide you can say. Then trill, r, ra. So, tip of the tongue touches the upper cavity and it vibrate, trill, ra, ra. If you say tip of the tongue touches the upper cavity and it vibrate, r, ra. So, it is trill. Then tap or flap. If the back tip of the tongue, back of the tip of the tongue touches the upper cavity, sing like a flap, then it is called flap or tap, ra, ra, ra. So, back of the tongue touches the upper cavity and produce that sound, that is why it is called tap or flap. Now, I go to the details discussion on that. Then if you see, sound can be classified two things, one is called oral vowel and nasal vowel. Vowel sound is described in term of tongue movement, I will come later on. Then diphthong, semi vowel and consonant. So, those are the, you can go through the slides, those you know, you can go through that. If you see how the sound is unique, it does not require the language. If I say ka for Hindi, ka for Bengali, ka for English, all is ka, sound ka. How the sound sequence is produced, then the language rule is come out. Okay. So, if I want to describe the each and individual sound which is produced by the human being and try to find out a symbol for each and individual sound. So, depending on the place and manner of articulation, what I do, I try to find out or try to assign a symbol to each particular sound. Okay. So, what I want, depending on the place and manner of articulation, I try to assign a symbol to each and every sound. So, maybe some language has some group of sound, some language may not have some group of sound. So, that is okay, but those sound which is exist in the language maybe exist in other language also. So, that is exist. So, sound which is distinct sound which is produced by different constriction and different kind of mechanism by the human vocal tract has to be assigned a particular symbol, that is called IPA, International Phonetic Alphabet. So, that is why it is called phonetic alphabet. I can assign a symbol to each and individual sound, okay, depending on the place and manner of articulation. Now, sound has a consonant, I already discussed. We have a consonant, we have a vowel, we have a diphthong, we have an approximant, those all has to be assigned some symbol. Okay. So, depending on the place and manner of articulation, we assign those symbols. If you see this chart, okay, there is another call. If you see the consonant which is written pulmonic, it can be pulmonic, I think non-pulmonic also I have symbol. So, most of the cases the sound which is produced during the airflow is from lungs to mouth is called pulmonic sound. If during the production of the sound, if the air flow in this direction, it is from lungs to mouth, then we call it is a pulmonic sound. Okay. Non-pulmonic, if the air flow is reverse, then we call it is a non-pulmonic sound. So, any pulmonic consonant, in that case the air is coming from lungs to mouth. So, that is the pulmonic sound. Now, pulmonic sound depending on the place and manner of articulation, they have assigned different symbol. If you see, this side is the place of articulation and this side is the manner of articulation. If you see the chart, this row wise is the place of articulation, column wise is the manner of articulation. Now, if you see plosive or stop, so if we see the plosive or stop, bilabial plosive. Okay. So, if I want to produce a bilabial plosive, that means I can draw it or I can go to here. So, you can get that animation. Let us like this, let us go to these pictures. So, if I want to produce a bilabial sound is here, yes, this is bilabial sound, I want to produce a bilabial sound. What is that? Two lips are closed, okay, lips are closed here. So, place of articulation is bilabial. Now, lips may be closed. What is the state of the glottist? Either glottist can open or glottist can close. If glottist is vocal cords or glottist or vocal cord is open, then I call unvoiced sound. If it is vocal cord is closed, then I call voiced sound. So, any bilabial plosive has two varieties, two manner of articulation depending on the source, vocal cords. Either it can be voiced or it can be unvoiced. So, if you see the chart, it is written P for unvoiced, B for next one is for voiced. So, it is two places, unvoiced and voiced. Similarly, if you see to or to, voiced, unvoiced, voiced, unvoiced, voiced, unvoiced. So, maybe some language does not have this sound, but other language may have this sound. Okay. So, if you see that consonant symbols in the IPA chart, depending on the voiced, unvoiced symbols are different, and depending on the manner, if you see the different symbol. Bilabial nasal is a manner M. Bilabial trill, if it is able to produce, this is capital B. Similarly, we have produced bilabial trill r, it is among the alveolar position. Then tap or flap, fricative. If I say we produce dental saw, but we may produce palatal saw or post alveolar palatal or post alveolar saw, okay. Lateral fricative, approximant, lateral approximant. If it is see that only voice part, unvoiced part is not there, that is why it is a single symbol. If you see single symbol, okay. So depending on the voice, that is voice or unvoiced, two sound, and depending on the manner in here, different sounds are there. We will describe later on, we will describe details. Similarly, non-pulmonic, I am not discussing non-pulmonic, and there is other kind of symbols are there. If you see the IPA chart downloaded from IPA site, the other kind of symbols are also there. Now I go for the vowels. If you see the vowel, how the vowel sound is specified. In case of production of the vowel, the constriction is not take place. The constriction is not there. What is there? The tongue movement. If you see, tongue can move front and back. If you see, your tongue can move either back or front. Back of the tongue can raise, or front of the tongue can come out front, and front of the tongue can raise. Okay. So depending on the tongue front and backward movement and tongue height, that means how the tongue is moving. Your upper palate is fixed, lower palate is moving, tongue is moving. So tongue height and tongue movement, frontness and backness and tongue height. So depending on the front or back where the vowel is produced, and depending on the tongue heights, all the vowels are described. Okay. So tongue height means if it is high, if tongue is raised high, then it is closed, almost closed. That is why it is also called closed, tongue closer. Or if it is low, tongue height is low, then it is also called open vowel. Okay. Sometimes we find some literature has closed or high, open or low, and depending on the tongue height and tongue forwardness, different symbols are there for different vowel sound. Okay. So vowels are classified or vowels are symbolified based on their vowel position, production position. Instead of constriction, here we call vowel, depending on the articulatory position, vowels are described. Either it can be high, low, or it can be front and back. And there is another things also. It is not considered, but yes, there is there, that if you see, some vowels are required lip movement also. If you either say, you can say the lip rounding, it is called lip rounding. Sometimes we round the lip and sometimes we do not round the lips. Here I am showing you the picture for different vowel production. If you see oo, lip are rounded. Okay. So lip rounding and the tongue position are describe the vowel sound. Okay. I am not playing the vowel. There is a different kind of vowel sound. You can, the PPT is here, you can play the sound. Now as an engineer, we do not know what is the vowel tongue height, tongue kind of things, how do you describe. So can I find out some parameter which will related to the tongue height and which is related to the tongue forwardness and backwardness? Yes, it is possible. If you see the format, vowels are described based on the formats, and the formats, it is F1 is nearly 500 Hz, F2 is 1.5 kilohertz, F3 is 2.5 kilohertz. I will come how it is 500 Hz like that. Now there is a relation that depending on the tongue height is related to the first format. Tongue front and backness is related to the second format, and lip rounding is related to the third format. So depending on seeing the, so this is a correlation, there is a close relation between the F1 and tongue height and it is correlation between the F2 and tongue lowerness, the tongue movement in the front and back. So, this is front and back. Okay. So, either I can, seeing the F1 and F2, I can classify whether this is a high vowel or low vowel. I can classify whether it is a front vowel and back vowel. So, the same place, same articulatory place can be simulated or can be modeled or can be placed in a formant measurement plane. So, I can back that, I can find out the frequency and I can plot them F1 and F2 plane, we generally call F1 and F2 plane, where the vowel sounds are classified. So, now if I say that F1 and F2 are classify the vowel sound, different kind of vowel sound. So, I can say the vowel, if the content or whether I said A or O, it depends on F1 and F2 and F3, some part of F3, whether lip rounding is required or not, that is F3. So, F1, F2 and F3 is describing the vowel, which vowel it is. So, you can say the content. Now, if you say the formant frequency, if F1 and F2 describing the vowel, different vowels, then why we require the higher formants? Higher formants may be communicate the speaker style or other information also. So, F1 and F2 mainly responsible for which vowel I have produced. If I change the F1 and F2, the sound, maybe A becomes O or U becomes O if I change the whole, change the format. So, F1 and F2 describing the vowel quality, or you can say the vowel, which vowel I have produced. Okay. And F1 and F2 related to the tongue height and tongue backness, front and back is F2, and tongue height and whether it is closed or open or low or high, that depends on the F1, and F3 is the lip rounding. Okay. So, next class I will take away to that animation and find out that different place of articulation. Okay. Thank you.